Okay, so screen is visible. Anyone reply me? Hello.
Yes, sir. Yes, sir.
Okay, so this is the section 1. We have discussed that is modes of heat transfer, then basic laws of heat transfer. So section 1 consists of 3 units are there. First unit is conduction. In that conduction there are small bits are there. First one, modes of heat transfer, then steady state heat conduction, and then unsteady state heat conduction. So we know that modes of heat transfer, that is basically there are three modes of the heat transfer, that is conduction, then convection, then radiation. So anyone tell me, is the conduction is possible in the liquid and gases? Anyone tell me what we think about that conduction? Conduction is nothing but transfer of heat because of the physical contact. So my question is whether conduction is possible in the gases and liquid. Anyone? Conduction is possible in liquid and gases. Anyone tell me?
No, sir.
No, it is not possible in liquid and gases. Okay, conduction is only possible in the solid. Okay, this is your conclusion, Harshvardhan.
Yes, sir.
Okay, anyone other? Yasar, Deepak,
Yes, sir.
it is possible in liquid or gases or not?
Not pos- not
No,
possible, sir.
not possible. Okay, so basically conduction is nothing but transfer of heat because of the physical contact. Suppose we have to consider this solid. So if suppose we have to heating the one end of that particular solid, then what will happen? Because of the lattice vibration, some particles are gaining the energy, and because of that energy, what will happen? That molecules will vibrate, and because of that vibration what will happen, that molecule transfer their energy to the adjacent molecule. So in this way the heat transfer is takes place from the one end to the another end. So in this solid conduction is takes place and heat transfer is takes place because of the lattice vibration and free electrons, lattice vibration and free electrons. So but conduction is also possible in the liquid and gases also. Liquid and gases also. So conduction is also possible in the liquid and gases. So how, in what way the conduction is takes place in the liquid and gases? So for that, because of the collision, so we have to consider the liquid. Suppose we have to heating that particular liquid. In that particular liquid maximum heat transfer will be takes place because of the convection, that is motion of the molecules. But in the liquid there is a possible of the conduction, and that conduction is possible because of the collision of the molecules. So whatever the molecules which are present in the liquid, that molecules will collide on the each other, means high temperature molecules are there, low temperature molecules are there. So because of the collision between these high temperature and low temperature molecules, what will happen? The heat transfer is takes place, and because of this collision the heat transfer is takes place. That is nothing but conduction, that is nothing but conduction. If the molecule is gaining the energy and he have changing their position from one location to another location, and because of that motion the heat transfer is takes place, that is nothing but convection. But in liquid there is a convection is also there, there is a conduction is also there. Conduction means what? In the liquid and the in gases, conduction is possible because of the collision of the molecules. So whatever the high temperature molecules are there, low temperature molecules are there, so these high temperature molecules will collide on the low temperature molecules, and because of this collision what will happen? Because of this collision is nothing but physical contact, and because of this physical contact what will happen? The heat transfer will be takes place, heat transfer will be takes place. So in the liquid and gases conduction is possible. Understood? In liquid and gases conduction is possible because of the collision, because of the collision, because of the collision. And we have to suppose we have to considering the gases. In that gases there is a possible of the conduction because of this collision, but the intermolecular force of attraction in solid is higher as compared to the liquid and gases. So intermolecular force of attraction is higher in the solid. Intermolecular force of attraction is less in the gases. But there are some high temperature molecules are there, some low temperature molecules are there, and because of these high temperature and low temperature molecules, there is some collision is takes place, and due to this collision is nothing but physical contact, heat transfer is takes place. So in liquid and gases, maximum heat transfer will be takes place because of the convection, because molecules are gaining energy and they are moving to the another location. Due to this, maximum heat transfer is takes place. But in liquid and gases, conduction is possible because of this collision. Because of this collision. So this is about the in liquid and gases conduction is possible. So conduction is takes place in the solid, liquid and gases also. Solid, liquid and gases also. Then after that, we have discussed about the basic laws of heat transfer. So related to the conduction, we know that Fourier's law of heat conduction is there. So what is the equation for that Fourier's law of heat conduction? That is Q is equal to K into A into dt by dx. That Q is nothing but rate of heat transfer. That is unit of rate of heat transfer is nothing but watt. Rate of heat transfer is nothing but, what is the unit of heat? That is joule. Rate of heat transfer is nothing but joule per second, and joule per second is nothing but watt. So rate of heat transfer is nothing but, it is having unit is watt. So we know that equation Q is equal to K into dt by dx. So from this equation, K is nothing but proportionality constant, and that proportionality constant means thermal conductivity of that particular material. So what is the definition of this thermal conductivity? Thermal conductivity is nothing but ability of material to conduct heat. What is meant by conductivity of any material? Suppose we have to consider the steel as a material, copper as a material. So these are the different materials, aluminum as a material. So what is the thermal conductivity of particular material? So what is mean by this thermal conductivity? Thermal conductivity is nothing but ability of material to conduct heat. Ability of material to conduct the heat. Means what? High thermal conductivity material is there. So means what? Having good conductor of heat. That material is good conductor of the heat. And suppose we have to consider another material having low thermal conductivity. So from that we said that the material is having good thermal insulator. Good thermal insulator. Understood? High thermal conductivity is nothing but good conductor of heat. Low thermal conductivity is nothing but good thermal insulator. Good thermal insulator. Then my question is that thermal conductivity depends on which factors? Anyone tell me? Suppose we have to consider the different materials. Suppose aluminum is there, copper is there, steel is there. So thermal conductivity of that particular material is depends on which factor? Anyone tell me any factor? On which factor thermal conductivity is depends? We have to assume that any material. Suppose we have to consider the aluminum as a material. We have to consider the copper as a material. So thermal conductivity of that particular material is depends upon which factor? Anyone tell me any factor? Hmm. Tell me any factor on which thermal conductivity of that particular material is depends. Anyone? Okay, all of you put your roll number in the chat box. You have to put your roll number once, only once. Don't put again and again. Only you have to put once your roll number in the chat box. So basically, thermal conductivity is depends upon the, there are four factors are there. What are the four factors? What is the material structure? We have to consider the aluminum, we have to consider the copper, then we have to consider the steel. What is the structure of that particular material? On that structure, the thermal conductivity depends. Then moisture content, we have to consider the material, how much moisture content in that particular material. On that thermal conductivity of that particular material is depends. Then density of material, whether the high density material is there or low density of material, low density material is there. So according to that, we have to consider the thermal conductivity of that particular material. Then pressure and temperature, how much pressure is acting on that particular metal, how much temperature of that particular metal. So on these factors, the thermal conductivity of thermal conductivity depends. That is, first factor is material structure, material structure. Then second one, moisture content. Then third one, density of that particular material, and pressure and temperature. on these factors the thermal conductivity of that material is depends. Thermal conductivity of that material is depends. My next question is if suppose we have to consider this solid. In solid, conduction is takes place. In liquid, conduction is takes place. In gases, conduction is takes place. Suppose we know that what is meant by thermal conductivity. Thermal conductivity is nothing but ability of material to conduct the heat. And this high thermal conductivity material is nothing but good conductor of heat. Then low thermal conductivity material is nothing but good thermal insulation. Then thermal conductivity depends upon which factors, that is material structure, then moisture content, then density of material, and then pressure and temperature. So my question is that suppose we have to consider one solid. If the temperature of that particular solid is increases, then what about the thermal conductivity of that particular material? Can anyone tell me? Can
will
anyone
increase, sir.
tell me? Hmm?
Will increase, sir.
Increases. For the solid, if temperature is increases, suppose we have to consider one solid, if we have increasing the temperature of that particular solid, we have increasing the temperature of that particular solid, then what about the thermal conductivity of that particular material? म्हणजे एखाद्या मटेरियलचं जर आपण टेम्परेचर वाढवलं म्हणजे सॉलिड मटेरियल आपण कन्सिडर करणार आहे. सो फॉर दॅट केस what is the effect on the thermal conductivity, whether thermal conductivity will increases or whether thermal conductivity will be decreases? Can anyone tell me?
Increases.
Increases. Okay, yeah, sir, answer is increases. What about others? Can anyone tell me?
Yes, sir, increases.
Increases. Okay, anyone? Another answer? Harshvardhan, what we think? Vidate?
Yes, sir. Increases, sir.
Increases. Okay, what basis we are saying that increases? What is the mechanism for that? We are saying that if temperature is increases, then thermal conductivity is increases. On what basis we are saying that? Any mechanism for that?
Sir, in solid, heat transfer takes place because of conduction, and conduction means vibration of lattice, and because of free electrons. So as we are
Okay.
increasing the temperature, the vibration of lattice goes on increasing, and that's why thermal
Okay.
conductance will increase.
Okay. So there is a one mechanism that suppose we have to considering the solid, we have to increasing the temperature and conduction is takes place. So in solid, conduction is takes place because of the lattice vibration and free electrons. In solid, conduction is takes place, and this conduction is possible because of the lattice vibration and free electrons. Suppose, so what is the standard for that? In solid, whatever the heat transfer is takes place, in that 70% heat transfer is takes place due to the free electrons. 70% heat transfer is takes place due to the free electrons, and 30% heat is transferred because of the lattice vibration. So from this concept, can anyone tell me if temperature is increases, then what about the thermal conductivity? Anyone? Whether this answer is same or some changes? What I am
Same, sir.
saying, same. Okay. What I am saying,
Yes,
suppose in conduction, whatever the heat transfer is takes place, in that conduction is possible because of the lattice vibration and free electrons. So because of this free electrons, 70% heat will be transferred, and because of the lattice vibration, 30% heat will be transferred. So by this statement, can anyone tell me if temperature is increases, then what about the thermal conductivity? Anyone? आता ह्याच्यावरून तुम्हाला काय वाटतं, टेम्परेचर वाढलं तर थर्मल कंडक्टिव्हिटी परत वाढणार असं म्हणताय का? तर बघा, so because of the, if for the solid we have to increasing the temperature, means what? If temperature is increases, means what? Molecular vibrations also increases. Molecular vibrations also increases. So because of this molecular vibrations, what will happen? They obstruct the flow of free electrons. ज्यावेळेला ही व्हायब्रेशन इन्क्रीज होणार आहेत, तर ही व्हायब्रेशन्स काय करणार आहेत, जे काय तुमचे इलेक्ट्रॉन्स फ्लो होणार आहेत त्या इलेक्ट्रॉन्सला काय करणार आहेत, ऑब्स्ट्रक्ट करणार आहेत. What is the concept? If we are increasing the temperature of that particular solid, because of that high temperature, molecular vibrations will be increases, and these high molecular vibrations obstruct the flow of free electrons. And suppose the flow of free electrons is reduces, then what is the effect on the thermal conductivity? तुमची molecular vibrations increase होणार आहेत, but for the molecular vibrations, what is the weightage of heat transfer? Only 30%, and 70% heat transfer takes place because of the free electrons. But due to this molecular vibrations, the flow of free electrons is obstructed. So due to that, for the solid, if temperature is increases, then thermal conductivity will be reduces. What is the concept? Due to this if temperature is increases, thermal conductivity will be reduces. Because of that, molecular vibrations are increases, but these high molecular vibrations obstruct the flow of free electrons. ज्यावेळेला तुमची व्हायब्रेशन्स एकदम फास्ट मध्ये होणार आहेत, त्यावेळेला त्या व्हायब्रेशन्स मुळे काय होणार आहे, जे का तुमचे इलेक्ट्रॉन फ्लो होत होते त्या इलेक्ट्रॉनच्या फ्लोला काय होणार आहे, obstruction होणार आहे. And because of that, what will happen? If temperature is increases, then thermal conductivity will be reduces. Okay, so this is about the solid. Then tell me about the liquid. What about the liquid? If temperature is increases, then what about the thermal conductivity? Can anyone tell me? Vidate, what is the concept related to the liquid? If temperature is increases, then what about the thermal conductivity? Because conduction is possible in solid, liquid and gases. This is our concept. So from that we have discussed about the, for the solid, if temperature is increases, then thermal conductivity will be reduces because of the obstruction in the flow of free electrons. Then we have to consider the liquid. For the liquid, suppose we have to increasing the temperature of that particular liquid, then what about the thermal conductivity of that particular liquid? Kai will sanga? Anyone tell me? For the liquid, suppose we have to consider the liquid. So for liquid, if we are increasing the temperature of that particular liquid, what is the effect of temperature on that particular liquid? What is the effect of the temperature on that particular liquid? काय होईल सांगा, जर आपण एखाद्या लिक्विडला टेम्परेचर दिलं तर त्या लिक्विड मध्ये काय बदल होईल? व्हॉट इज द चेंज इन दॅट पर्टिक्युलर लिक्विड? एनीवन? Okay, suppose we have to consider the liquid. If we are increasing the temperature of that particular liquid, then what will happen? The density of that particular liquid will be reduces. Density काय होणार आहे? रिड्यूस होणार आहे. आता आपला कन्सेप्ट काय आहे? जिथं फिजिकल कॉन्टॅक्ट जास्त असेल, जिथे इंटरमॉलिक्युलर फोर्स ऑफ अट्रॅक्शन जास्त असेल, तिथं कंडक्शन काय होणार आहे? इझिली होणार आहे. बट फॉर द लिक्विड, इफ वी आर increasing the temperature, what will happen? The density of that particular liquid will be reduces. Means what? If density of that particular liquid is reduces, means what? The physical contact between the molecules is reduces. म्हणजे जिथं नंबर ऑफ मॉलिक्युल्स जास्त असणार आहे तिथं मॉलिक्युलची संख्या काय होणार आहे? कमी होणार आहे. कारण व्हॉट इज आवर कन्सेप्ट? इफ टेम्परेचर इज इन्क्रीजेस, देन means what? Density will be reduces. And if whatever the liquid we have to considering, the density of that particular liquid is reduces, means what? The number of molecules will be reduces. And if number of molecules will be reduces, means what? The physical contact will be reduces. So means what? If temperature is increases, then automatically thermal conductivity will be reduces. Thermal conductivity काय होणार आहे? लिक्विडचं जर टेम्परेचर वाढवलं तर काय होणार आहे? त्याच्यामुळे त्या लिक्विडची डेन्सिटी कमी होणार आहे. डेन्सिटी कमी होणार आहे म्हणजे मॉलिक्युलची संख्या कमी होणार आहे. आणि मॉलिक्युलची संख्या कमी झाली तर काय होणार? फिजिकल कॉन्टॅक्ट काय होणार आहे? कमी होणार आहे. And because of this less physical contact, what will happen? The thermal conductivity of that particular liquid will be reduces. Thermal conductivity of that particular liquid will be reduces. So all of you understood, for the solid, if temperature is increases, thermal conductivity will be reduces. And similarly for the liquid, if temperature is increases, then thermal conductivity also reduces. Then from these two cases, now tell me what is the effect for the gases? For the gases, if you are increasing the temperature of that particular gases, then what is the effect on the thermal conductivity? Can anyone tell me? काय होईल सांगा आता. आता मी सॉलिड साठी तुम्हाला सांगितलं कन्सेप्ट. देन आय हॅव टेल the concept related to the liquid. Now we have to tell me what about the gases. If temperature of that particular gases is increases, then what is the effect on the thermal conductivity? Anyone?
It will get decreases.
It will decreases. Okay. Any other answer?
Increases, sir.
Increases. Okay.
Increases, sir.
Increases. Okay. So Rohit, tell me what basis we are saying that thermal conductivity will be increases? On which concept or on which basis?
So if we increase the temperature, the collision between the molecules will increase, and that's why the thermal conductivity increases.
Correct. So clap for the Rohit. Correct answer is there. So for the gases, if temperature is increases, thermal conductivity will be increases. Now we have discussed the two cases, that is for solid and liquid. If temperature is increases, then thermal conductivity will be reduces. But for the gases, if temperature is increases, for the gases, what will happen? If the temperature is increases, then thermal conductivity also increases. So what is the reason behind this? Because of the molecular vibrations are increases. If suppose we have to consider one gas, we have given the temperature for that particular gas. Because of that temperature, what will happen? These molecules will vibrate continuously, and because of that, these molecule higher vibrations of these molecules, what will happen? The collision is increases. Collision between that molecules is increases. Means suppose we have to consider the small instant of time. In that instant of time, the collision between two molecules is increases, and because of this collision, maximum contact between these different molecules is takes place. बिकॉज ऑफ दिस हायर कोलिजन, म्हणजे जो काय गॅस आहे त्याला आपण टेम्परेचर दिलं त्याच्यामुळे काय होणार आहे, ते काय जे काय मॉलिक्युल्स असणार आहेत ते कंटिन्युअस मोशन मध्ये असणार आहेत. मोशन मध्ये काय असणार आहेत म्हणजे व्हायब्रेशन्स मध्ये असणार आहेत. अँड बिकॉज ऑफ दॅट व्हायब्रेशन्स दे आर ट्रान्सफरिंग देअर एनर्जी टू दी ऍडजस्टंट मॉलिक्युल्स. म्हणजे सगळे मॉलिक्युल्स एकमेकांच्या कॉन्टॅक्ट मध्ये कसे येणार आहेत, कंटिन्युअस येणार आहेत. त्याच्यामुळे जो काय फिजिकल कॉन्टॅक्ट तयार होणार आहे बिटवीन टू मॉलिक्युल्स, बिकॉज ऑफ दॅट व्हॉट विल हॅपन, मॅक्झिमम हीट ट्रान्सफर विल बी टेक्स प्लेस. And if heat transfer will be increases, means what? Thermal conductivity also increases. म्हणजे तिथं काय होणार आहे, व्हायब्रेशन्स इन्क्रीज होणार आहेत बिकॉज ऑफ दिस मॉलिक्युलर कोलिजन. अँड बिकॉज ऑफ दिस कोलिजन व्हॉट विल हॅपन, मॅक्झिमम हीट ट्रान्सफर विल बी टेक्स प्लेस. सो फॉर द गॅसेस, इफ टेम्परेचर इज increases, then thermal conductivity also increases. Thermal conductivity also increases. So this is related to the thermal conductivity and its variation with temperature. Understood? So this is the sub point of unit 1, that is modes of heat transfer, that is thermal conductivity and its variation with the temperature. For the solid, temperature is increases, then thermal conductivity will be reduces. For the liquid, temperature is increases, then thermal conductivity will be reduces. And for the gases, if temperature is increases, then thermal conductivity is increases. Okay. Then next point, steady state heat conduction. So we know that, anyone tell me what is meant by steady state and unsteady state? What is the definition for that? Our next subpoint is steady state heat conduction. So what is the definition for the steady state? Anyone? And after that, next point is unsteady state. So anyone tell me, steady state means what? Tell me what is meant by steady state. So steady state is nothing but temperature does not changes with respect to time. Suppose we have to consider any component. Suppose we have to heating that particular component. After some time, what will happen? The temperature of that particular component is does not changes with respect to time. Suppose we have to measuring the temperature of that particular component at 2 p.m. So that is 100 degrees Celsius. And suppose we have to checking the temperature of the same component at the 3 p.m. The temperature is same, that is 100 degrees Celsius. Then we said that that is nothing but steady state. Means what? Temperature does not changes with respect to time. Means time is continuously increasing, but temperature is constant. That is nothing but steady state. And on this concept we have to discuss the different derivations. That is, what are the different derivations? That is, derivation of generalized heat conduction equation in Cartesian coordinate system. So basically there are three coordinate system we have to consider, that is Cartesian coordinate system, then we have to consider the cylindrical coordinate system, then we have to consider the spherical coordinate system. And by using these three systems we have to derive the general heat conduction equation. We have to derive the general heat conduction equation. Means what? We have to considering the, sometimes we have to consider the object. In that object we have to considering the internal heat generation. Means that object is continuously producing the heat inside that particular object. Then we have to consider the steady state. Sometimes we have to consider the steady state, means whatever the factor with respect to time, that factor becomes zero. So in this steady state heat conduction chapter we have to derive the three generalized heat conduction equation in the Cartesian coordinate system, then cylindrical coordinate system, then spherical coordinate system. And by using that equation we have to derive the equations for the different shapes. What are the different shapes we have to consider? That is, plane wall is there, then cylinder is there, then sphere is there. So what is the heat distribution for that particular plane wall? We have to calculate the temperature of that particular plane wall. So suppose there are different problems on that plane wall. What is the temperature of, if suppose temperature of one end is given, then we have to find out the temperature of the other end. Then similarly we have to derive the equation for the cylinder. So from that equation we have to find out the different locations, temperature of the different locations. So in this way we have to cover this सब पॉइंट, दॅट इज स्टेडी स्टेट हीट कंडक्शन. म्हणजे जो काही आपला सेकंड टॉपिक, सेकंड बीट जे असणार आहे स्टेडी स्टेट हीट कंडक्शन, इन दॅट वी हॅव टू डिराइव दी जनरलाइज्ड हीट कंडक्शन इक्वेशंस फॉर दी three coordinate system, that is Cartesian coordinate, then cylindrical coordinate system, and then spherical coordinate system. So from these coordinate systems we have to derive the equations for the plane wall, then cylinder, then sphere, and then composite. So composites means we have to consider the only plane wall, then we have to attach the different shapes of that particular plane wall and find out the temperature distribution for that particular composite wall. Then there is a composite cylinder is also possible, then composite sphere is also possible. So for that different shapes we have to calculate the heat transfer from that particular shapes. म्हणजे प्लेन वॉल मधून किती हीट ट्रान्सफर होणार आहे, then we have to calculate the how much heat is transferred from the cylinder, then we have to calculate the how much heat will be transferred from the sphere. Okay, so this is related to the steady state heat conduction equation. Means in this topic we have to cover the all derivations and problems on that particular derivation, then in this topic we have to discuss about the critical radius of insulation for cylinder and sphere. So what is basic concept related to critical radius of insulation? So we know that insulation is reducing the flow of heat, but what is the concept related to the critical radius of insulation, or critical thickness of that particular insulation? So what is meant by critical thickness or critical radius? The thickness up to which heat flow increases. Critical thickness कशाला म्हणायचं बघा, the thickness up to which heat flow increases and after which heat flow is decreases. म्हणजे इन्सुलेशनचा थिकनेस इतका पाहिजे, इतका असतोय. क्रिटिकल थिकनेस ऑफ इन्सुलेशन कशाला म्हणायचं आहे की त्या थिकनेस मध्ये काय होणार आहे, हीट ट्रान्सफर रेट पहिल्यांदा इन्क्रीज होणार आहे आणि त्याच्यानंतर हीट ट्रान्सफर रेट काय होणार आहे, डिक्रीज होणार आहे. तो जो थिकनेस असणार आहे इन्सुलेशनचा, दॅट थिकनेस इज नथिंग बट critical thickness of the insulation. So for that we have to derive the derivation for the cylinder and sphere. So from that derivation we get the final equation as a RC is equal to K by H for the cylinder and RC is equal to 2K by H for the sphere. तर हे आपल्याला काय करायचे आहे, डेरिव्हेशन्स डिराइव्ह करायचे आहेत, त्याच्यावरून आपल्याला काय मिळणार आहे, हे दोन इक्वेशन्स मिळणार आहेत. आणि बाय युजिंग दॅट इक्वेशन्स वी हॅव टू सॉल्व द डिफरंट प्रॉब्लेम्स रिलेटेड टू द क्रिटिकल रेडियस ऑफ द इन्सुलेशन. समजले का बघा, क्रिटिकल थिकनेस कशाला म्हणायचं की ज्या थिकनेस पर्यंत तुमचा हीट ट्रान्सफर रेट इन्क्रीज होणार आहे आणि त्याच्यानंतर हीट ट्रान्सफर रेट काय होणार आहे, डिक्रीज होणार आहे. तो जो थिकनेस असणार आहे दॅट थिकनेस इज नथिंग बट क्रिटिकल थिकनेस ऑफ द इन्सुलेशन. आता सपोज वी हॅव टू कन्सिडर द एक्झाम्पल ऑफ इलेक्ट्रिक केबल. सो व्हॉट इज आवर रिक्वायरमेंट फॉर दॅट पर्टिक्युलर इलेक्ट्रिकल केबल? दॅट इज maximum current will be ट्रान्सफर्ड फ्रॉम दॅट पर्टिक्युलर वायर. एक केबल आहे, तर आपल्या केबलचं फंक्शन काय असतं, तर केबल मधून मॅक्झिमम करंट काय व्हायला पाहिजे, पास व्हायला पाहिजे. बट सपोज for that particular cable the temperature of that particular cable is continuously increases, then what will happen, the burning of that cable is takes place. So on which basis that insulation of that particular wire is considered, म्हणजे जी काही वायर आहे त्याला किती थिकनेसचं इन्सुलेशन लावायचं हे कशावरून ठरवलेलं असते. सो दिस थिकनेस इज डिपेंड्स अपॉन दी क्रिटिकल थिकनेस ऑफ दी इन्सुलेशन. समजले का बघा, जी काय आपली केबल असते तर त्या केबलवरती जो काही इन्सुलेशन असतं तर त्या इन्सुलेशनला काहीतरी मेकॅनिझम आहे. ते तुमचा जो काही इन्सुलेशनचा थिकनेस आहे तो तुम्हाला एकदम जास्त पण लावून चालणार नाही, एकदम कमी पण लावून चालणार नाही. सो इट डिपेंड्स ऑन दी कन्सेप्ट क्रिटिकल रेडियस ऑफ दी इन्सुलेशन. म्हणजे आपली जी केबल आहे ते केबलचं जर टेम्परेचर कंटिन्युअसली इन्क्रीज होत असेल, फॉर दॅट केस व्हॉट विल हॅपन, द बर्निंग ऑफ दॅट पर्टिक्युलर केबल इज टेक्स प्लेस. सो वी हॅव टू design the insulation of that particular wire in such a way that the maximum current will be passed through that particular wire, but also maximum heat will be transferred into the surrounding. So whatever the heat is produced inside that cable, that heat will be utilized into the surrounding. So how it is possible, by using that concept that is critical radius of the insulation. तर आता आपल्याला माहित आहे क्रिटिकल थिकनेस ऑफ इन्सुलेशन म्हणजे काय असणार आहे, त्या थिकनेस पर्यंत हीट ट्रान्सफर रेट काय असणार आहे तुमचा मॅक्झिमम असणार आहे, त्याच्यानंतर काय होणार आहे, कमी होणार आहे. सो फॉर दी डिझायनिंग ऑफ दॅट पर्टिक्युलर इलेक्ट्रिकल केबल वी हॅव टू मेंटेन दी थिकनेस ऑफ दॅट इन्सुलेशन बिलो दी क्रिटिकल रेडियस. म्हणजे जर त्या क्रिटिकल रेडियस पेक्षा जर थिकनेस तुम्ही कमी ठेवला तर काय होणार आहे, तुमचा हीट ट्रान्सफर रेट इन्क्रीज होणार आहे. and because of that what will happen, whatever the heat which is produced inside that particular cable, that heat will be evaporated into the surrounding. म्हणजे ती हीट कुठे होणार आहे, सराउंडिंग मध्ये पास होणार आहे, त्यामुळे तुमची केबल बस्ट होणार नाही. सो वी हॅव टू design the cable in a such way that having critical thickness of the insulation or thickness of radius of that particular insulation is less than critical thickness of the insulation. आणि दुसरी जर केस आपण कन्सिडर केली फॉर दॅट रेफ्रिजरेशन पाईप. So our aim is to maintain the temperature or we have to reduce the temperature of that particular refrigeration pipe. So for that case we have to maintain the thickness of that insulation in such manner that the radius of that insulation is greater than the critical thickness. जर तुमची क्रिटिकल पेक्षा रेडियस जास्त झाली तर हीट ट्रान्सफर रेट काय होणार आहे, कमी होणार आहे. म्हणजे हीट तुमची काय होणार आहे, डिसिपेट होणार नाही. पण केबल मध्ये काय करायचे, आपल्याला मॅक्झिमम हीट डिसिपेट करायचे आहे. सो वी हॅव टू make the thickness of that insulation below the critical radius. So this is the concept related to the critical radius of insulation. That part we have to cover detail in the time of the lectures, that is the derivation. Then we have to solve the problems on that particular cases, that is critical radius of the insulation. Okay, then next topic is unsteady state heat conduction. So what is the unsteady state heat conduction? So unsteady state heat conduction is nothing but, we know that steady state is nothing but temperature does not changes with respect to time. But for the unsteady state, what is meant by unsteady state? Temperature is changes with respect to time. Means suppose at 2 p.m. 100 degrees Celsius is there, at 3 p.m. 150 degrees Celsius is there. So with respect to time, the temperature is continuously changes. That is nothing but unsteady state. Okay, so in that topic we have to consider the Biot number, Fourier number, we have to derive the equations, we have to calculate the what is the equation for the Biot number, then we have to derive the equation for the Fourier number, then significance, then we have to consider the lumped heat capacity analysis. Means we have to considering the unsteady state, and by using that unsteady state concept we have to derive this equation. Then we have to go for the unit number 2, that is extended surfaces. So we know that what is meant by extended surfaces. There are different shapes of extended surfaces. It may be straight, it may be tapered, it may be spline, it may be pin. So these are the different types of the extended surface. What are the applications? आता extended surfaces means nothing but it is the It is nothing but extended surface. Whatever the engine or whatever the component we have to considering, on that component we have to increasing the, or we have to extend the surface by using these fins. Fins is nothing but extended surfaces. So by using these extended surfaces, we have to transfer the maximum heat. We have to transfer the maximum heat. So we know that what are the different applications of these extended surfaces. That is, radiator is there, then engine cylinder head is there, then electrical motor body is there. तुम्ही जर इलेक्ट्रिकल मोटर बघितले असेल किंवा इंजिन बघितलं असेल तर इंजिन वरती काय केलेले असतात, अशा एक्सटेंडेड सरफेस असतात, असे फिन्स असतात. तर व्हॉट इज द फंक्शन ऑफ दिस फिन्स? टू ट्रान्सफर दी मॅक्झिमम हीट इनटू दी सराउंडिंग. मॅक्झिमम हीट इनटू दी सराउंडिंग म्हणजे जी काही मोटरमध्ये किंवा ती जी काही सिलेंडर असणार आहे त्याच्यामध्ये जी काही हीट प्रोड्यूस होणार आहे, आवर एम इज टू ट्रान्सफर दॅट हीट इनटू दी surrounding, because if the temperature of that particular component or the particular motor is increases, then there is a possible of burning of that particular component. So that we have to use these extended surfaces. तुम्ही जर इलेक्ट्रिकल मोटर बघितले असेल तर त्या मोटरवरती काय केलेले असते, असे एक्सटेंड अशा ज्या फिन्स लावलेले असतात. तर ते फिन्स का लावलेले असतात? व्हॉट इज द रिझन? बिकॉज ऑफ दिस व्हॉट विल हॅपन, the surface area of that particular component will be increases, and because of that surface area, maximum heat will be transferred into the surrounding. Maximum heat is transferred into the surrounding. So what are the different applications of these extended surfaces? That is nothing but radiator is there, then engine cylinder head is there, electric motor bodies are there, then different electronic equipments are there. In that we have to use these extended surfaces, and because of these extended surfaces, maximum heat will be transferred into the surrounding, and because of that, savage of that particular component is takes place. So this we have to cover in the extended surfaces topic, that is unit number 2. That is, we have to discuss about the types of the surface, then applications, then governing equation of that extended surfaces. We have to consider the three cases, that is, infinitely long fin is there, then convective tip is there, then adequate long is there, and then we have to calculate the fin effectiveness and fin efficiency. So what is meant by fin efficiency? Fin efficiency is nothing but actual heat transfer divided by maximum heat transfer. By using that, we have to find out the efficiency of that particular fin. Then we have to discuss about the fin effectiveness. What is meant by fin effectiveness? That is heat transfer with fin and heat transfer. It is ratio of heat transfer with fin and heat transfer without fin. म्हणजे हीट ट्रान्सफर रेट ज्यावेळेला आपण फिन यूज करणार आहे त्यावेळेला किती असणार आहे आणि विदाउट फिन किती असणार आहे. बाय युजिंग दॅट वी हॅव टू कॅल्क्युलेट दी fin effectiveness. Then after that we have to discuss about the unit number 3, that is radiation. So in that radiation we have to discuss about the what is meant by radiation. So radiation is nothing but transfer of energy in the form of electromagnetic waves. There is no requirement of any medium. So radiation heat transfer occurs most effectively in the vacuum. So it obeys the laws of light. So this concept we have to cover in the unit number 3. Then we have to discuss about the absorptivity. Then what is meant by reflectivity. So we know that what is meant by absorptivity. It is the ratio of amount of heat absorbed by the material to the total energy incident on the body. म्हणजे एखादी किती हीट आपण इन्सिडेंट केली त्यातली किती ऍब्सॉर्ब केली, दॅट इज नथिंग बट ऍब्सॉर्बिव्हिटी. व्हॉट इज मीन बाय रिफ्लेक्टिव्हिटी? किती एनर्जी आपण किती हीट आपण सप्लाय केली त्याच्यातली किती रिफ्लेक्ट झाली, दॅट रेशियो इज नथिंग बट रिफ्लेक्टिव्हिटी. सिमिलरली ट्रान्समिसिव्हिटी. देन वी हॅव टू डिस्कस अबाउट द इमिसिव्ह पॉवर, देन टोटल इमिसिव्ह पॉवर. Then what is meant by emissivity? Emissivity is nothing but what is meant by emissivity? It is emissive power of a body to the emissive power of a black body. So that ratio is nothing but emissivity. Then we have to discuss about the concept of black body, gray body. Okay. So what is meant by black body? Black body is nothing but black body is the one which neither reflects or not transmits any part of the incident radiation but absorbs all of it. म्हणजे त्याच्यावर जी काय आपण एनर्जी हे करणार आहे ती काय करणार आहे, ऍब्सॉर्ब करून घेणार. म्हणजे अल्फा इज इक्वल टू 0, म्हणजे ऍब्सॉर्बिव्हिटी काय असणार आहे, 1 असणार आहे, आणि बाकीची ट्रान्समिसिव्हिटी अँड रिफ्लेक्टिव्हिटी इज इक्वल टू 0. दॅट इज नथिंग बट ब्लॅक बॉडी. देन वी हॅव टू डिस्कस अबाउट द laws of radiation, that is Kirchhoff's law, Wien's displacement law, Planck's law. Then we have to go for the Lambert's cosine rule. Then intensity of radiation, energy exchange by radiation between two black surfaces. So in this case we have to consider in the two black surfaces, and the heat exchange between two surfaces takes place because every body is emitted the radiation above 0 Kelvin. So whatever the body we have to considering, that body is emitted the radiation. Then we have to go for the concept of radiation shape factor. So according to shape factor, we have to calculate the heat transfer for that particular shape. Then energy exchange by radiation between two gray surfaces. For two gray surfaces, we have to calculating the heat transfer rate, and then we have to discuss about the radiation network method. In that, we have to discuss about the radiation shield. By because of that radiation shield, what is the effect on the heat transfer is takes place. So this part we have to cover in the unit number 3, that is radiation. In radiation, we have to cover the this part. Then we have to go for the unit section number 2. In that, unit number 4 is convection. So in that convection, there is a forced convection, and basically what are the types of the convection: forced convection and natural convection. So what is meant by natural convection? What is the another name for the natural convection? That is nothing but free convection. So what is the difference between free convection and forced convection? So free convection is nothing but the transfer of fluid takes place due to the density difference. डेन्सिटी डिफरन्स मुळे जे काय तुमचं लिक्विड आहे ते ट्रान्सफर होणार आहे, त्याच्यामुळे हीट ट्रान्सफर जी केली जाणार आहे दॅट इज नथिंग बट नॅचरल कन्व्हेक्शन. म्हणजे एखादा जर हॉट ऑब्जेक्ट आहे तर तो थंड कशामुळे होते? बिकॉज ऑफ दी नॅचरल कन्व्हेक्शन. अँड व्हॉट इज मीन बाय फोर्स्ड कन्व्हेक्शन? Suppose we have to using the external devices. If suppose blower is there, if suppose pump is there, if suppose fan is there. So because of that external devices, we have to given the motions of that particular liquid or particular gases, and because of that heat transfer takes place. That convection is nothing but forced convection. समजतंय बघा. नॅचरल कन्व्हेक्शन मध्ये जी काही मोशन असणार आहे ती मॉलिक्युलला कशामुळे असणार आहे? बिकॉज ऑफ दी डेन्सिटी डिफरन्स, अँड बिकॉज ऑफ दॅट हीट ट्रान्सफर इज टेक्स प्लेस. But in the forced convection, the heat transfer is takes place or motion of the molecules is due to the external devices. And what are the external devices we have to use? That is pump is there, blower is there, then fan is there. By using that, we have to reducing the temperature of that particular component. That type of convection is nothing but forced convection. Forced convection. So in that, we have to cover the hydrodynamic and thermal boundary layer. So that point already we have discussed in the fluid mechanics. Then we have to discuss about the dimensionless analysis. Then we have to see the different numbers, Biot number, Nusselt number, and according to that we have to do the dimensional analysis, and we have to find out the different relation between these dimensionless numbers. Then similarly we have to same part we have to cover in the natural convection, that is dimensional analysis. Then what are the dimensionless number related to the natural convection and their physical significance. So that part we have to cover in the natural convection. That part we have to cover in the natural convection. Then fifth topic is boiling and condensation. Fifth topic is boiling and condensation. So can anyone tell me what is mean by vaporization? Anyone? Vaporization कशाला म्हणतात? So basically there are three concepts. Vaporization is there, then evaporation is there, then boiling is there. So what is the difference between this vaporization, evaporation and boiling? So all three are different or they are same? Can anyone tell me what is mean by vaporization? Anyone? Vaporization कशाला म्हणायचं? श्रीराम?
Yes, sir. Liquid gets converted into vapor.
Okay, correct. What is meant by vaporization? It is the process by which liquid changes to vapors. Liquid चं जे काही conversion vapors मध्ये होणार आहे, that process is nothing but vaporization. Now tell me what is meant by evaporation? Anyone? Rohit? What is meant by evaporation? Yes sir. Sonone, More. Tell me what is mean by evaporation? Simple question I am asking. What is mean by evaporation? So we know that vaporization is nothing but process by which liquid is converted into the vapor. Now tell me what is mean by evaporation, and after that we have to tell me what is mean by boiling. Evaporation and boiling. Evaporation कशाला म्हणायचं? Can anyone tell me? कोण सांगतंय? Evaporation. So evaporation is nothing but vaporization only at surface of liquid. म्हणजे जर एखादं लिक्विड तुम्ही त्या लिक्विडला जर टेम्परेचर देत असतील तर त्या केसमध्ये जे काही सरफेसला जे काही व्हेपरायझेशन होत आहे, व्हॉट इज मीन बाय इव्हॅपोरेशन? इव्हॅपोरेशन इज नथिंग बट vaporization only at surface of liquid. Vaporization only at surface of liquid, that is nothing but evaporation. That is nothing but evaporation. Then what is meant by boiling? Evaporation and boiling is same or different? Can anyone tell me? Evaporation and boiling, rhythm?
Dif- different.
Different. So what is the difference between evaporation and boiling?
Boiling is takes place when the water is boiled, but
Okay.
evaporation is not only when the water is boiled. Evaporation is takes place at lower temperature also.
Okay. So means what? Evaporation is vaporization only at surface of liquid. Means at that case some less temperature is there. And for the boiling, what will happen? Vaporization that occurs throughout the liquid. Means whatever we are considering the liquid, in that liquid throughout vaporization is takes place. Means throughout that liquid is converted into the vapor. That process is throughout that particular liquid, that is nothing but boiling. Okay, understood? Vaporization is nothing but liquid is converted into the vapor, that is nothing but vaporization. Then what is meant by evaporation? Evaporation is nothing but vaporization only at surface of liquid. Evaporation is nothing but vaporization only at surface of liquid. And what is meant by boiling? Vaporization that occurs throughout the liquid. म्हणजे जे काय तुमचं लिक्विड आहे त्याच्यामध्ये थ्रूआउट काय होणार आहे? लिक्विडचं कन्व्हर्जन वेपर्स मध्ये होणार आहे. दॅट इज नथिंग बट बॉइलिंग. Okay, then what is meant by condensation? Can anyone tell me what is meant by condensation? Condensation. So condensation is nothing but conversion of vapor to liquid. Vaporization मध्ये काय होत होतं तर लिक्विडचं कन्व्हर्जन वेपर्स मध्ये होत होतं. And what about the condensation? Condensation is nothing but conversion of vapors to liquid, that is nothing but condensation. So in that condensation there are different types. Film wise condensation is there and drop wise condensation in there. Then we have to discuss about the pool boiling curves. So what way that particular liquid will be boiled, that part we have to discuss in the pool boiling curve. Then we have to discuss about the introduction to heat pipe. So what is the use of heat pipe? So heat pipe is, we have to discuss about the construction of that particular heat pipe, then working, then advantages and application. That part we have to cover in the boiling and condensation. तर heat pipe चं function काय असतं? To transfer the heat from one end to the another end, one end to the another end. And in that particular heat pipe there are three sections, that is condensation section is there, evaporation section is there, and adiabatic section is there. So by using that three sections we have to transfer the maximum heat from the one end to the another end, one end to the another end. So that is the concept related to the heat pipe. In detail we have to discuss in that topic, that is unit number 5, boiling and condensation. And last topic, that is unit number 6, that is heat exchanger. We have to discuss the heat exchanger. So we know that what is meant by heat exchanger. Heat exchanger म्हणजे काय असणार आहे? A heat exchanger may be defined as an, it is a equipment which transfer the energy from a hot fluid to a cold fluid. Heat exchanger मध्ये काय होणार आहे तर एनर्जी कुठून कुठे ट्रान्सफर होणार आहे? फ्रॉम दी hot fluid to a cold fluid with maximum rate and minimum investment. मॅक्झिमम रेट मध्ये जी काही हीट असणार आहे ती काय? हीट एक्सचेंजर. म्हणजे आपल्याला काय करायचे? हीट एक्सचेंज करायचे फ्रॉम दी hot body or a hot fluid to the cold fluid, that is nothing but heat exchanger. So what are the examples of the heat exchanger? This automobile radiator, then regenerator, then intercoolers, then cooling tower. So these are the some of the examples of the heat exchanger, that is heat transfer from the hot fluid to cold fluid is takes place, that is nothing but heat exchanger. So then classification of heat exchanger. So there are different types of heat exchanger are there. Direct contact heat exchanger, indirect contact heat exchanger. In that, indirect regenerator is there. So according to the relative direction of fluid motion, parallel heat exchanger, counter flow heat exchanger, then cross flow heat exchanger is there. Then concentric tube type heat exchanger is there. Shell and tube type heat exchanger is there. Then multiple shell and tube type heat exchanger is there. Compact heat exchanger is there. Then according to the physical state, condenser is there, evaporator is there. So this condenser and evaporator also heat exchangers are there. So then we have to go for the LMTD and NTU method. So by using that we have to calculate the temperatures at the end, and by using that NTU method we have to calculate the heat transfer rate. So these are the different methods. So we have to do this analysis for the parallel and counter fluid exchanger, that is LMTD analysis and NTU method. Then we have to calculate the falling factor. Then we have to calculate the overall heat transfer coefficient. So we have to derive the equation for that overall heat transfer coefficient, and we have to solve the problems on that particular derivation. So basically in the heat exchanger, only 2-3 theoretical questions are there. What is the classification of heat exchanger? Then there are derivations of LMTD method, then derivation of NTU method is there, and then different problems related to this LMTD method and NTU method is there. So this is related to the syllabus of the heat transfer. This is the syllabus of the heat transfer. In tomorrow's lecture, we have to discuss the what is the different experiments we have to conduct in the HMT lab, that is heat transfer lab. So today we have to stop here. So those who are not putted their roll number in the chat box, they have to put their roll number. So those who are putted their roll number, they have to ignore. Okay. So we have to stop here. Remaining part we have to cover in the next lecture. So thank you very much.